the next compound which we are going to discuss for boron, and that is orthoboric acid or just boric acid, H3BO3. It is also written as BOH thrice. Here boron undergo sp2 hybridization. If we know the electronic configuration of boron, 1s2, 2s2, 2p1. So the ground state electronic configuration is like this way. So this is a ground state electronic configuration. In an excited state, the electronic configuration become 1s2, 2s1 and 2p2. Now here 1s and 2p orbitals undergo hybridization, giving you sp2 hybrid orbitals. Now that half-filled sp2 hybrid orbitals are overlapped by half-filled p orbital of oxygen, and there is a formation of a sigma bond. Now interestingly, if you observe in this excited state electronic configuration, there is a vacant p orbital which remains unhybridized. Okay, so that vacant p orbital can accept lone pair of electron. We will see that in the reactions of orthoboric acid. Now, how will you prepare boric acid? There are various methods for the preparation of boric acid. The first method is from borax. Borax is hydrolyzed in acidic condition, gives you orthoboric acid. So it may be HCl, it may be H2SO4. In both the cases, we are getting orthoboric acid. The byproducts are NaCl and Na2SO4, which are actually more soluble than orthoboric acid. It is also prepared by hydrolysis of boron halide except BF3. So BCl3, BBr3 or Bi3 on hydrolysis actually gives you orthoboric acid. The byproducts are corresponding hydrohalic acids. Diborane boron hydride, B2H6 on hydrolysis gives you orthoboric acid. The byproduct is hydrogen. Boron nitride, Bn, on hydrolysis gives you orthoboric acid and ammonia gas is liberated. Commercially, orthoboric acid is prepared by using ore colemanite. So colemanite first hydrolysis gives you orthoboric acid, but there you are getting calcium hydroxide. Now both are soluble in water. So how will you remove calcium hydroxide? It is removed by passing sulfur dioxide, so that we are getting calcium hydrogen sulfide, which is insoluble in water. So colemanite actually treated with aqueous solution of sulfur dioxide, so that we are getting calcium hydrogen sulfide and boric acid. So now these are the methods of preparations of boric acid. Now we will go for the reactions of boric acid. Boric acid as contains 3 hydrogen atoms which are directly attached to oxygen. So it expected to be tribasic, because this 3 hydrogen atom should be replaced when it reacts with alkali, but it does not happen. Orthoboric acid is a weak acid. Rather, these 3 hydrogen atoms are not replaced. Rather, orthoboric acid is an acid because it accepts a lone pair of electron. So it is a Lewis monobasic acid. So when it reacts with H2O, it gives you this. Therefore, orthoboric acid is called as Lewis monobasic acid, because it accepts one lone pair of electron, and it is accepted because there is vacant p orbital. Orthoboric acid can be heated. So what is the action of heat on orthoboric acid? When it is heated to 370 Kelvin, we are getting metaboric acid. So there is a loss of one H2O, which on further heating gives you at 410, around 400 Kelvin, we are getting H2B4O7, that is tetraboric acid. So there will be a dimerization and tetramerization is possible. which is further heated red hot. So there is a loss of H2O and we are getting boric anhydride. So this is a very important reaction. What is the action of heat on orthoboric acid? So on heating 370, first metaboric, then tetraboric, then boric anhydride. Now this reaction we have already done in a borax. So it is a continuation reaction. Rather it is a test for the presence of boron in any compound. So boric acid when treated with ethyl alcohol gives you what? Triethyl borate. Now triethyl borate burn or after ignition burns with green edge flame. So that is a characteristic test for boron. So when we are dealing with basic radicals or acidic radicals as a borate, okay, we can use this test for the conformation test for boron. So this is all about the methods of preparations and reactions of orthoboric acid and at the same time the structure. Now boric acid is a very important compound. It is used mainly in a preparation of borosilicate glass. Now borosilicate glass is a very hard glass. It is mainly unaffected by heat and many of the various chemical reagent except HF, hydrofluoric acid. But mainly it is a very tough and heat resistant. So microwave utensils or other whenever we require a high heating, the borosilicate glass is used. So in the preparation of that glass we are using orthoboric acid. Also it is used for the preparation of enamels or a glaze in a pottery. It is used as a preservative in a foodstuff or in a milk. A very dilute solution of orthoboric acid is act as a disinfectant and therefore it is used for eye infections under the heading of boric lotion. So boric lotion is actually used for eye infections, which is a very dilute solution of boric acid. So that's all about the group 13 elements. Now we have to move for the next group, that is carbon family, group 14 elements, that we'll see in the next session. Thank you.